Hello everyone, welcome back to another kinetic tutoring episode. Today we're going to be continuing topic 1.3 of AP Chemistry. I started this last time, but I didn't quite have the time to finish it without dragging on the video for too long, so I decided to make 1.3 a two-part video. So let's jump right back in. This question is asking us a couple questions about this data set that we're provided. We're given a sample that has carbon and hydrogen that is burnt in the presence of excess oxygen gas. Sorry about that. And the carbon will be converted into CO2 and H2O. So as we can see here, the mass of the sample is 5 grams, and it will be turned into 10.99 grams of CO2 and 6 grams of H2O. So there we have that. So the first part of the problem is asking us to determine the mass of carbon. So the way we're going to do this is by, first we need to find the percent composition of carbon in CO2, because we need to find out how much carbon there is in this 10.99 grams of CO2. And the reason we do this is because we know all of the carbon is going to be in the CO2 that is produced, because CO2 and H2O are the only molecules that are left. So let's start with that. The percent composition of carbon is going to be it's going to be the mass of carbon, 12.01, divided by the mass of carbon plus the mass of two oxygen atoms, which will be 32.0. So let's do this calculation right here. 12.01 divided by 44.01. This gets you around 0.2728, which translates to, 27-ish%. Now we multiply that by the mass of CO2, 10.99, and what we're going to get is a number that is going to be rounded to 2.999, as you can see here. So there are 3 grams carbon. Now let's see how many grams of hydrogen are produced, and we do the same thing for this one. 2 atoms of hydrogen weighs 2.02 grams, and then we have 2.02 plus 16, so we get 18.02. 2.02 divided by 18.02 gives you somewhere around 11.2%. Now multiply that by the 6 grams, and you'll get 0.672 grams. If we're going to, I'm going to round that to 2 sig figs, so 0.67 grams. Now it says determine the mass of oxygen present in 5 grams of the compound. So we know that there's 5, the compound is going to be 5 grams, as we can see here, but only 3.67 grams are carbon or hydrogen, meaning that the rest is going to have to be oxygen. So we get 5 minus 3 minus 0.67 gives us roughly 1.33 grams of oxygen. And now it's asked us to find the empirical formula of the compound. The way we do this is we find the one with the smallest amount in grams. So as we can see, we have 0.67 grams of hydrogen. Or sorry, no, that's not how you would do it. First, you have to find out how many moles of each element there are. And the way you would do that is by finding their mass and dividing by their molar mass. 3 divided by 12.01 will give you roughly, let's do the calculation actually. 3 divided by 12.01, 0.25 moles carbon. Now let's do for hydrogen. 0.67 divided by 1.01. That gives you around 0.66 moles. And keep in mind this isn't the notation for moles, it's MOL. I was just doing that for the sake of efficiency. 0.66 moles of hydrogen. And then we have 1.33 divided by 16 gives you 0.083. Now what you want to do is you want to take this and you want to take the smallest value. We have 0.083 moles of oxygen. Divide the other ones by this 0.083. So let's start off with carbon. 0.25 divided by 0.083. Automatically off the top of my head, I know it's going to be 3 just off the way it looks, but let's double check. Yes, we get 3.012. 3.01, we can just call that 3. So for every 1 oxygen, there's going to be 3 carbons. Now we need to do the same thing with hydrogen. So we have 0.66 divided by 0.083. This gives you 7.95, roughly 8 hydrogens. So for every 1 oxygen, there's 3 carbons and 8 hydrogens. So I'm going to write that as C3H8O. There you go. There's your empirical formula. Now let's move on to the next question I have prepared. Here we go. Another type of situation that involves mass and mole ratios involves a substance known as a hydrate. Hydrate is a substance in which water molecules are included in the chemical formula. These substances are often ionic compounds in which water molecules are bounded to the ions in the crystal structure. The hydrate salt can be heated to remove the water through evaporation, forming an anhydrous salt. 2 examples of anhydrous salts and hydrates are listed in the table below. Question 20 asks us to calculate the mass of CuSO4 present in this 25-gram sample of CuSO4 times 5H2O. So the way you're going to do this is by finding the percent composition and multiplying by 25. The percent composition of this is going to be CuSO4 over the entire thing, CuSO4 plus 5H2O. Keep in mind that that dot does not mean multiplying, it is still addition. That's just the hydrate, notation. So H2O, the mass of that's 18.02 times 5 will give you 90.1. So we have 90.1 plus this over this. So let's find out what CuSO4 is. O4 is 64, sulfur is 32.06. So we get 92.06 plus copper, 92.63 plus 92.06 plus 63.55. So the mass of CuSO4 is 155.61. So let's do this math real quick. 155.61 divided by, in parentheses, 155.61 plus 90.1. We get 0.63 if you round to 2 decimal places. I'm just going to keep it like it is because I'm not going to go to 2 sig figs in the decimal place until after the full conversion. And now let's multiply this by 25 grams. 15.83. All right, so 15.83 grams. 15.83 is the mass in grams of CuSO4 that is present in the 25-gram sample. And it asks us to calculate the mass of H2O present. And you could do the same thing, but flip it around, like put H2O on the top instead of CuSO4. But we also know that this sample is made up of two things, H2O and CuSO4. And we know how much CuSO4 is in there. So 25 minus that amount will simply be the amount of H2O. And once you do that calculation, it does come out to 9.17 grams. And question 21 is similar, but it asks us to calculate the percentage of H2O by mass. So it's the same thing. It's actually a little bit easier because you don't have to find the mass in a particularly sized sample. Excuse me, sample. So all you have to do, 2H2O CaCl2 plus 2H2O. There it is. That's the equation. Let's plug in our values. H2O is 18.02. So you get 36.04 something plus 36.04. CaCl2, that's 40.08 plus 2 chlorines, which is 35.45 times 2, 70.9. 110.98. Let's do this calculation. 36.04 divided by, in parentheses, 110.98 plus, I forgot my decimal, let me just go back, 110.98 plus 36.04. You get around 0.2451367161. That's what you get on the calculator. Multiply that by 100. 24.51367161. And now let's round to 2 sig figs after the decimal. You'll get 24.51%. So there you go. That's how you would go about solving those two problems. Hopefully this video was useful. If it was, I hope you guys will like and subscribe. It means a lot to the channel and it helps out a lot. And if there's anything you're confused about, any comments, questions, or concerns, leave them down in the comment section below. I will try my best to respond to them. And yeah, I'll see you guys next time.